Hey everybody, welcome back to day 2 of chapter 10.1, comparing two proportions. Our objective today is going to be to construct and interpret a confidence interval for a difference between two proportions. And we are going to use the SPDC process that we talked about in chapter 9. All right, so remember that confidence intervals have this particular format. Start off with a statistic or a point estimate, and let me write that down as well, point estimate, and you add or subtract this entire portion here, which we call a margin of error. Margin of error. I will get a better stylus someday, I promise. All right, so it's a point estimate plus or minus a margin of error. Now, in the margin of error, you have your critical value, which for proportions is a z-star value, and you have a standard deviation of your statistic. So, notice on this section, our point estimate is the difference in the two sample proportions. All right, so here it's p hat 1, p hat sub 1 minus p hat sub 2, plus or minus a z-star times your standard deviation. Okay, now, this is what the first one here is what it would look like if you knew the true population proportion. So if you knew P, it would look like this. But oftentimes we don't know the true proportion. We definitely don't know it for either. So we go and we use what's called the standard error. And that means replacing all P's for P hats. Okay, so this is the standard error that we use when we can't find our population standard deviation because we don't know the true value of P. Now, don't be alarmed by this formula. It's very similar to the one that you learned in chapter 9. Okay, this is a formula you used in chapter 9. Radical p hat times 1 minus p hat divided by n. Now notice, all you do for this new standard deviation is you just add this standard error of the second proportion. Okay? And I'm going to talk a little bit about why we add it, and if you still don't understand it, don't worry. Just as long as you can plug those numbers in, you'll be fine. Okay? But here, again, is a little bit more about why the bottom one is called standard error and why the top one is just the regular standard deviation. All right, so even further back in chapter 7, we talked about getting the standard deviation of a difference. So we are finding the difference in P sub 1 minus P sub 2. Now, the reason why we don't subtract the standard deviations is because we talked about this Pythagorean theorem of statistics. When you want to get the standard deviation of a difference of two independent random variables, you actually have to add, because when you have two variables, you have more variability. You don't get less. So you actually never subtract. You end up adding. And then we talked about this. We called it the Pythagorean theorem of stats. Pythagorean theorem of statistics. And that's just a little bit of the reasoning as to why you add two different standard deviations or standard errors and then take a square root. Okay, so here is the full formula for what's called the two-sample z-interval for a difference of two proportions. So please definitely stop the slideshow and copy this down. This is a very, very important formula, and it helps us construct the confidence interval in full. All right, so we're going to try to use this on a problem. And first, note that you are given this portion of that confidence interval formula. It's the standard error of your sample statistic of p hat sub 1 minus p hat sub 2. It's given to you right here in the formula sheet. Okay, we're not going to use this one because we don't know the true value of either proportion. So we're going to use this one to the right. All right, now before we get into our example, just a quick reminder. We've typically focused on random sampling, but for the first time, we're going to look at and construct an interval from a comparative experiment. And just remember, we talked about something called the scope of inference, and we've got to be careful about the generalizations that we make from any experiment. And a lot of it has to do with this chart. Was there random selection from the population? And were individuals randomly assigned to groups? So in this example that we're going to talk about, there was not random selection from the population, but there was individuals randomly selected to groups. So a lot of experiments are like this. You can't randomly select people from your population because typically, like if it's a disease, study on heart disease or whatnot, not everyone has heart disease. You're just going to get a lot of volunteers that show up, want to be a part of your experiment. So we won't be able to make an inference about the whole population, but we could make an inference about cause and effect. So you'll see that on the next slide. No inference about our full population, but we can make an inference about cause and effect. All right, so pause the slide, and I know there's a lot here. Pause the video, excuse me, and read through this, and then we're going to construct a 99% confidence interval for the difference in the proportion of these two groups. All right, so in this experiment, there are two groups that are taking two different types of anti-inflammatory drugs to help ease back pain. As you can see, that gentleman, he looks like he's in some severe distress. So the researchers conducted this experiment. So there was 112 patients, 112 volunteers. One group was given a treatment of naproxen and Valium, and another group was given a treatment of naproxen and a placebo. Okay, and there are some values here. 39 of 57 who took naproxen and Valium reported lower back pain, compared with 43 of 55 in the other group. All right, so let's go through the whole SPDC process and answer part A. So we're going to state, so the way you would state this is you would say, I want to construct a 99% CI for P sub 1 minus P sub 2, which is the true difference in those two proportions, where P sub 1 is the true proportion of patients like these. The reason why we're using this interesting wording is because we are not randomly sampling from our population. Again, these were volunteers or patients that were recruited, so we can't say for all patients. So we say the true proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium for a week. P sub 2 is the true proportion of patients like these who would report reduced lower back pain after taking naproxen and placebo for a week. Okay? And again, we keep our tenses in the, typically tend to keep them in the present tense. We try to avoid past tense because then it sounds like we're referring to the sample. Our plan is a 2-sample Z interval for P sub 1 minus P sub 2. In Chapter 9, we looked at 1-sample Z intervals for P. Now we're comparing two different proportions. All right, so the random condition is satisfied by randomly assigning patients to take either naproxen and Valium or naproxen and placebo. Notice we left the 10% condition off. When you are not randomly sampling from a population, you don't need to check the 10% condition. And that occurs when you have experiments like these. Okay? Now, large counts, we're going to use the actual counts here, 39 and 18 for the P sub 1 group, and 43 and 12 for the P sub 2 group, and these are all greater than or equal to 10. All right. Now comes the math. Here comes the do part. And I will teach you how to do this on the calculator tomorrow. I'm not going to show you just yet because I want you to go through it in full. But tomorrow I will show you how to do this on your TIs. All right, so for the P sub 1 group, we had 39 out of 57. And that's 0.684. For the P sub 2 group, the naproxen and placebo group, we got 0.782. All right, so remember that here, we define the interval as P1 minus P2. So the order does matter, And it says here we wanted the difference in the proportion of patients like these who would report reduced lower back pain after taking naproxen and Valium, which is our P1, and naproxen and placebo is our P2. So because they gave it to us in that order, we are going to put our P sub 1 first, 0.684 minus 0.782. All right, plus minus, our Z star is 2.576. Okay, where did we get that? Let me show you guys where this is on your table B, which is in your textbook. I looked at 99% confidence and an infinity degrees of freedom. Okay, so remember, 99% infinity degrees of freedom. So right over here, I'm going to highlight it. In infinite degrees of freedom, 2.576. Okay, so that's where this value is coming from. The one that you see right here. All right, now these are constructed by using P sub 1 times 1 minus P sub 1, or pardon me, P hat sub 1 times 1 minus P hat sub 1 divided by N sub 1, and then you do the same for your P hat sub 2, and that had a different sample size as well. So if you did all of this right, this is all called, again, your margin of error. Your margin of error should be 0.214. Okay, so practice that on your calculator. Make sure that this entire value, make sure this is all 0.214. All right, and here's your confidence interval. And notice you can get a negative number, and we'll talk about that for part B. All right, so here's our conclusion. We are 99% confident that the interval from negative 0.312 to 0.116 captures the true difference in the proportion of patients like these who would report reduced back pain after taking naproxen and Valium versus after taking naproxen and placebo for a week. Okay, so this was the order because the order was naproxen and Valium, naproxen and placebo. We keep that P1 minus P2 order just like so. Now the answer could also be written, it depends on the way the question is asked, but if you were to write this answer out, sorry about that guys, my computer's not cooperating here. Now if you wrote the answer in this form, with the negative in front of 0.116 and 0.32, that would be equivalent to reversing the naproxen and Valium group and the naproxen and placebo group. That would mean we would put naproxen and placebo first and naproxen and Valium second. But the way that the question was stated, again, just following the order, naproxen and Valium versus naproxen and placebo, this is the answer we want to state. Okay, so this one would work if the question was stated in the other way. All right, here's a good sentence frame to write down. The negative should be right here, by the way. And just copy that down in your notes, and you can use it and replace all those highlighted numbers with context. Numbers or words with context. I'm going to wait for this until we're ready for it after we talk about hypothesis tests. But my last minute here, I wanted to give you guys this problem here. Take a quick look and we will discuss it after you read through it. Okay, so we're constructing a 95% confidence interval for the difference between the proportion of all U.S. teens and adults who use social networking sites. All right, I'm going to quickly take you through SPDC before we run out of time. So this is also in your slideshow, so just take a look at it. This does involve random sampling, so we are using the 10% condition. Keep that in mind. All of our calculations down here are done random 10% large counts. Okay, so again, I'm going to speed through it because I don't have a lot of time. Here is our mathematical work. We are using 1.96 because that's the critical value of the 95% confidence level. That's our Z star. It is 1.96. That's one of the most common ones that I told you guys to memorize, or you could look that up in Table B.